In this video, let us study how to solve simultaneous equations using Crammer's rule. Now, let us take simultaneous equations. Ax plus by is equal to m and cx plus dy is equal to n. These are simultaneous equations. It can be solved using elimination method or substitution method. But here we are going to study how to solve these equations using matrices. For this purpose, we have to convert these equations into matrix equation form. And for making the matrix equation form, we have to create matrices out of these equations. For creating matrices, we have to consider the coefficients of these variables. Now, the coefficient of x here is a and that y is b. Then here in the second row that will be c and d. Now, considering a, b, c, d, that is the coefficient of all the variables in the equations, we are going to create a matrix of a, b, c, d. We have to put it in that order itself. So in order to keep it in order, we have to first see whether the equation is in order. Both equations must be in the same order. That is, first is the x variable component, then comes the second y variable component. And here also, first is x variable component and then y variable component. So both of these equations are in order. And in the right hand side elements are also there. So both of them are in the same order. Hence, it is easy for us to form a matrix out of it. Matrix of A, B, C, D. A, B, C, D. That is how we form this matrix. And then our next matrix is matrix of the variables. Matrix of X, Y. Then coming to the right hand side, we have to form a matrix of these elements also. So that is equal to matrix of Mn. Now this is in matrix equation form, that is Ax is equal to B. A matrix is the matrix formed with the coefficients and X matrix is the matrix formed with the variables and B matrix is the matrix formed with the elements in the right hand side. Ax is equal to B is the matrix equation form. So, when we get a simultaneous equations, we have to convert that equation into matrix equation form for solving it using matrices. And now, let us take an example. Simultaneous equations are given here. They are 2x minus 3y equal to 3 and 4x minus y equal to 11. We have to convert it into matrix equation form. So the coefficients of the variables are taken to form matrix A. That will be matrix of 2 minus 3, 4 minus 1. And then the X matrix comprising of the variables, matrix of X, Y. And then that is equal to a matrix comprising of the elements in the right hand side, matrix of 3, 11. Thus, we get it in the form Ax is equal to B, which is the matrix equation form. So, even if we are using matrices for solving the equations as such, making use of the inverse method, or whether we are applying the Crammer's rule method, we have to convert the equations into matrix equation form. For both these methods, this expression into matrix equation form is compulsory. And the next step onwards, both the methods differ. Thus, we got A as matrix of 2 minus 3, 4 minus 1 and B as matrix of 3, 11. Now we have to find A1. That is obtained by replacing the first column of A by B. So, A1 will be equal to matrix of 3 minus 3, 11 minus 1. Next, we have to obtain A2. A2 is obtained by replacing the second column of A by B. So A2 is equal to matrix of 2, 3, 4, 11. And then our next step is to find the value of unknowns using a formula. And the formula is x is equal to determinant of A1 divided by determinant of A, and y is equal to determinant of A2 divided by determinant of A. We have already got three matrices now, A, A1, A2. Using this A1, A2 and A, we have to find x and y. That is, we have to find the determinant values of all the three matrices A, A1 and A2. And then apply the formula. To find the value of x, we have to do this division as determinant of A1 divided by determinant of A, and for getting the value of y, we have to divide determinant of A2 with determinant of A. And now let us see how to do it. We got A as matrix of 2 minus 3 4 minus 1, and A1 is matrix of 3 minus 3 11 minus 1, and A2 is matrix of 2 3 4 11. First of all, let us find out determinant of A. That will be 2 into minus 1 minus 4 into minus 3. So determinant of A is 10. Now determinant of A1, it is 3 into minus 1 minus 11 into minus 3. Therefore, determinant of A1 is 30. Now determinant of A2, 2 into 11 minus 4 into 3. So determinant of A2 is again 10. Now apply the formula. X is equal to determinant of A1 divided by determinant of A, that is 30 divided by 10, 3. So x is equal to 3. And now to find the value of y, we have to apply the formula determinant of A2 divided by determinant of A, that is 10 divided by 10. Hence, y is equal to 1. So we got the solution for these equations. X is equal to 3 and y is equal to 1. And in the same manner, we can solve simultaneous equations in three variables also. Let us take an example. Here, three equations are given. Same as we have done before, we have to find the matrix equation form, or we have to express these equations in the matrix equation form. This is A into X, that is equal to B. So, it became in the matrix equation form AX is equal to B. The A is formed using the coefficients of the variables in the equations and put it in the same order. So, the first row will be 3, 2 and 1. That is corresponding to the variables in the first equation. These values. Then second row 2 minus 3, 3, and the third row 1, 1, 1. And then X matrix is the variable matrix. Matrix of X, Y, Z. And here the right hand side 6, 2, 3 in that order itself. So we got it in Ax is equal to B form. Thus, we get A matrix and B matrix. Now, we have to find A1 by replacing the first column of A by B. So, A1 is equal to matrix of 6, 2, 1, 2 minus 3, 3, 3, 1, 1. That is, the first column of A is replaced with B. Next, we have to obtain A2. That is obtained by replacing the second column of A with B. So, A2 will be matrix of 3, 6, 1, 2, 2, 3, 1, 3, 1. And then A3 is obtained by replacing the third column of A with B. So, A3 will be matrix of 3, 2, 6, 2 minus 3, 2, 1, 1, 3. Thus, we get A1, A2 and A3. And our next step is finding the determinant of each of these matrices. The determinant of A is calculated as minus 11 and the determinant of matrix A1 is also calculated to be minus 11. And the same way, the determinant of A2 is also found to be minus 11 and the determinant of A3 is also calculated as minus 11. Now we can apply the formula. X is equal to determinant of A1 divided by determinant of A. That is minus 11 divided by minus 11. Hence X is equal to 1. And in the same manner, Y is found as determinant of A2 divided by determinant of A. That will also be minus 11 divided by minus 11. Hence Y is equal to 1. So Z will be the same minus 11 by minus 11 by applying the formula determinant of A3 divided by determinant of A, and that is also 1. Hence all the variables have got values 1. X is equal to 1, Y is equal to 1 and Z is equal to 1. Now this is the solution for the given simultaneous equations. Now, the same solutions will be obtained even if we apply the other method that we have already studied in the other video to solve simultaneous equations using matrices. And we can even apply the substitution method or elimination method to find the simultaneous equations without using matrices. And in all these methods, including the Crammer's rule method, we get the same solution. Thank you for watching this video. For more videos, subscribe the channel.